One, on the green circuit math worksheet, we have a parallel circuit, and all of the current that we have here takes off down this path, but at this point it has a choice. It can go right, or it can go straight. Here it can turn right, or it can go straight. Here it has to turn right. So all of the current travels down these three branches. So all we have to do is add the three currents together to get the total current. That's how a parallel circuit works. You can add your currents together and you get the total current. Remember, on a series circuit, the current is the same throughout because there's only one path to follow. Also, just a quick little addition to this, if I said, which one of these branches has the greatest resistance, what would your answer be? If you think about it, as the current comes down these, the one with the least current has the greatest resistance. Okay, it's kind of like if you're trying to escape out of the school and there are principals at each door, you're going to try to go out the door with the least resistance. Less people will try to go out the door with the most resistance. Okay, so more resistance, less current. Less resistance, more current. Okay, moving on to number 2. We talked about this equation in class, so do you remember that? We have voltage and resistance, and R1, R2, we've got to figure out everything else. Okay, so first of all, we could start right here and get our total current. If you can get your current, that will help you through the entire circuit every time. So right here, our current, if I put my finger over this, it's V over R. So 12 divided by 9 is 1 1/3 amps. Or if you want to put it in fractions, all of these are equivalent answers. And the current takes a right here, and then it takes a right here, and then it takes a right here, and then it takes a right here, and it's back to the battery. But there's never any other path for it to go down except for this one single loop. So the current around the entire loop is the same. So we don't get to add the currents here like we did on parallel, where there's a choice, but the current, all of it, only has one path to follow. So the current is the same throughout. Okay, so once I know that, I know I and R here. So if I want to get V, V is I times R, V2 is I2 times R2, and that gives me these two voltages, but I don't have V3 or R3, so I had to figure out how to get those. I use my total resistance on a series circuit equation and solve for R3. So R3 is equal to 9 minus 3 minus 2, which gave me 4 ohms. Once I knew I and R, V is equal to I times R. But also notice that if I add these three together, I should get 12 volts. Okay. If you use 1.3 going across here, and then you get your V's that way, you might only add up to like 11.7, but that's all because of rounding. You're still doing it the right way. Okay, number 3. Right here we have a parallel circuit. I have a lot of kids that think this is series to begin with. It's drawn a little bit different than the one we drew in class, but the current comes this way, and it can turn left or it can turn right. So it has a choice. If it has a choice, it's parallel. Okay, so remember, on a parallel circuit, the voltage pushes the same. We don't split this and put 5 and 5, but they're both 10. Okay, so in other words, this resistor does not reduce the voltage push on this resistor, and vice versa. They both get the same push. The push comes from right here. And so nothing is lost at this point. Once we pass this, we've lost 10 on both, but now it's just down to 0. 0 voltage the rest of the way. But we still have current flowing back to the battery. Alright, so V is 10 volts, and if I know V and R on each one, then I is equal to V divided by R. I is equal to V divided by R, I is equal to V divided by R. But let's see here. Let's see here. I've skipped something here. I don't have the total resistance here. So I do have VNR here and VNR here. So I could get this and this, and then 0.5 plus 0.3 is 0.8, and then I could solve for the total resistance. R would be equal to V over I. Or I could practice using my total resistance equation for parallel, where it's 1 over RT is equal to 1 over R1 plus 1 over R2, etc. So in my calculator I plug in 1 divided by 20 plus 1 divided by 30 equals 0.083. Now remember, 0.083 is 1 divided by RT, but I want RT. So if I hit my inverse button on the calculator, then it will give me the inverse of what I've got here. So let's do that real quick. 1 divided by 20 plus 1 divided by 30 gives me this number, but this number is equal to 1 over RT. So if I hit the inverse button, x to the negative 1, it gives me 12 volts. Once I know this, then I can do V over R, and I also get 0.8 amps. So a couple different ways you can go about getting that. Okay, watch the next two videos for the rest of the worksheet.